Yes. So this is input-output matrix, input-output matrix, where they have given us a small illustration here. We have matrix A, and then we have matrix D. Matrix A, if you can recall, is what we called the technical coefficients or technological. And then D, ladies and gentlemen, is what we called the final what here? The final demand. D is the final demand. So I would want somebody to tell me, what do you think of this I? I should be what dimension? How many rows? How many columns? This I. Somebody talk to me, this I. The I should be equal to what here, somebody? Leo si kama jana. Leo mbona hamna story? Jana tuliongea vizuri sana. Jana mlikuwa mnazungumza, mlikuwa mna participate. Leo nataka hata ikuwe much better. Yeah, identical according to Lucy here should be 3 by 3. Why should it be a 3 by 3? To rhyme with matrix A, which is a 3 by 3. To rhyme with matrix A, which is a what here? Which is a 3 by 3 matrix. Which is a 3 by 3 matrix. So in this case here, how do we get to write our, thank you very much, Benny. So in this case here, our I has to be 3. So 3 is 1, 0, 0. Then we start here with 0. The next one will be 1, 0. And then we have 0, 0, what here? 0, 0, 1. 0, 0, 1. Which they would want me to come here and deduct. They would want me to come here and deduct my A. So my A here is 0 0.3, 0 0.2, 0 0.1, 0 0.1, 0 0.15, 0 0.2, 0 0.12, 0 0.28, and then 0 0.52, 0 0.52. So could you kindly go ahead and do the differences? Subtract for us. Subtract for us. Yes, subtract for us. Let me see whether I'll be able to get a student who will be able to subtract this thing for us. So like the first figure will be 1 minus 0.3. 1 minus 0.3 gives me what figure? Somebody? 0.7. And then we have 0 minus the second figure. 0 minus the second figure, this gives me minus 0.2. And then we have the third one, which is 0 minus 0.1, which gives me minus 0.1. Then we go to the second row. Second row, the first one will be minus 0.1. The second, the middle one will be 0.85. Let me move slowly here. Remember, it is the second one here and the second one here. So I'm subtracting this one and 0.15, which will give me 0.85. The third element here will be 0 minus 0.2, which gives me minus 0.2. And then we come here, we have minus 0.12, we have minus 0.28, and then the last one will be 1 minus 0.52. 1 minus 0.52 gives me 0. What here, somebody? Gives me 0.48, like that. Gives me 0.48, like that. Now, ladies and gentlemen, I've been able to get, according to this equation, I've been able to get I minus A. Once I get my I minus A, what do you think will be the next thing to be done? What do you think will be the next thing to be done? What do you think will be the next thing to be done? By the way, all the students who are very aggressively participating, I normally give them a present. Like I can see James's contribution. Somebody talk to me. Remember, what I've done here is per Bodimas. Yeah, much I can see what you're saying is per Bodimas. Bodimas wants me to, first of all, work with whatever is in the brackets. But happy I'm seeing kakitu. Hapo juu naona kakitu kananiambia universe. Na kama ni inversion, then the first thing that I need to do, as Venny tells me, as Match tells me, I need to get the determinant. I need to get the determinant. And determinant, it will be determinant of I minus A with speed. I would want to see who will be the first student to get the determinant of this particular value. Remember the concept of duplicating the columns, first column, second column. Who will be able to give me the determinant? Please just duplicate them slowly, try it out. giving me these parameters, determinant kadra, na ngoja nipatie determinant Lucy, James, match. Mimi nangoja determinant, na kama umesahau no problem, I'll be able to help you. So long as you really are making some effort to see whether you can remember, it's my work to remind you, but I just want you to put some effort. Put some effort. So I'm waiting for that student who will be able to get the determinant for us. The first student to get the determinant for us, we need to reward that student today. And I've seen Miriam's concern. She wasn't there for yesterday's class, but now when I asked that, she never spoke because I knew. Right? So determinant of I minus A. Wacha tuone kwanza wa kwanza kupata hiyo. Determinant of I minus A. What do we have? Fortunately, Miriam, we have those videos for this. If I share with you after today's class, please don't run away. Just hang around. Because after all, you're going to get some concepts. But of course, with whatever knowledge you'll get today, plus our videos, which I'll be able to send to you after the class, you should be able to grasp everything. So determinant of A, according to 𝐨𝒻𝒻, is getting 0.219. 0.219. How about Lucy? How about Kadra? How about much? I want to see whether there is a student who will be able to confirm what 𝐨𝒻𝒻 has given us. Am I waiting for anybody to give me a figure really? Ama sisi wote tu hakuna chenye tunaona? Haya, so ladies and gentlemen, niwasaidie. Si ndio matrix ya I minus A. Kama ndio matrix ya I minus A, for me to get the determinant, what I'm supposed to do is to come and duplicate the first two columns here. So we have 0.7, we have minus 0.1, we have minus 0.12. Veni amekataa. Thank you very much, Veni, for coming out boldly with your figure. Yes. So come and duplicate The first two columns, Miriam, the first two columns here, you'll come and duplicate them here. So we have minus 0.2, we have 0.85, and then we have minus 0.28 like that. It's a rule. You duplicate the first two columns. And then remember that the primary diagonal, the major primary diagonal, is the one that starts from the first element. So this first element will have a diagonal cutting across 3, cutting across 3. And then you go and pick the next one, cutting across 3, cutting across 3. And then you go to the next one, you pick, there are 3 primary diagonals. There are 3 primary diagonals. There are 3 primary diagonals. So with these 3 primary diagonals, could you kindly give me, first of all, the products of each one of them, and then, ladies and gentlemen, we shall be able to sum them. So come and give me what we call the PPD. PPD. Miriam naandika in full, kwamba PPD is product of primary diagonal. PPD is product of primary diagonal. So the product of the primary diagonal here will be 0.7 times the second figure, which is 0.85, times the third figure, which is 0.48, plus, there are 3 of them, plus the second diagonal here will be minus 0.2 times minus 0.2 times minus 0.12. There are 3 of them, plus the third one, the third diagonal will be minus 0.1 times minus 0.1 times minus 0.28. And then now you should be able to give us what we call the product of primary diagonal. Kadra, thank you very much. Kadra, after she's been able to put all these through her calculator, the consolidated figure according to Kadra is 0.113. 0.113. Is there somebody else who can confirm that for sure this is the correct figure? PPD. Can someone confirm that this is the correct figure? PPD. Just take your calculator and try. Bwana James, get your calculator and try to see whether 0.7 times this plus this. Are we going to get 0.113? First of all, Match, please help me the PPD. Lucy, give me the PPD. They're getting different figures for PPD. And I want to believe it is because of what here? The signs. Because of the signs. Somebody must be missing out on some sign. Somebody must be missing out on some sign. Somebody must be missing out on some sign. PPD. I'm looking for PPD. So if I look at what Match is really giving me, it's quite close to what James has. So it means that this PPD has to be 0.2876 or 88 or 0.2. No, it's quite different from what James has. It's quite different from what James has. Please try to give us the impetus, that speed that we need for us to be able to move very fast. Even if you're getting a different answer, don't fear arguing out your answer. Give us your answer. Give us your answer. Give us your answer. Give us your answer. Mary is saying it's supposed to be 0.278. The same figure that Areba gave us earlier on. The same figure that Areba gave us earlier on. So Match, please, I'm still returning the ball back to you. You never dribbled this ball very nicely. You gave me something that was half-baked. So please dribble it again. Try with your calculator to see whether you'll be able to get that 0.278. Try again. Try again. Try again. Even Kadra, you gave me a different figure. Try to see now whether with your calculator and the workings that I have here, try to see whether you'll be able to get the PPD of 0.278. Match says 0.278. How about the other students? Lucy, Kadra, sijakusikia bado. Nimeona mwanafunzi mwingine ameingia anaitwa Victor. Thank you very much, Victor, for joining us. The other students, are they able to get that? 0.278. Kutoka hapo sasa, tunaenda straight away kwa PSD. PSD, product of secondary diagonal. Product of secondary diagonal, what do we have? Product of secondary diagonal, product of secondary diagonal. Ladies and gentlemen, remember how our secondary diagonal behaves like. Remember how our secondary diagonal behaves like. The first one will be the lagging one cutting across through 3. That is the first one. The second one will be this one here cutting across, which is parallel to this, cutting across 3. And then, of course, we have the last one like that. We have the last one like that. So meaning that I've got to be very careful for me not to miss out on a sign. I have to be very careful. So we have here minus 0.12 times 0.85 times minus 0.1 plus. So times. Plus, we come and pick the second one. The second one, what do we have? I can see minus 0.28 times minus 0.2 times 0.7 plus. We go to the third one. The third one, we have 0.48 times minus 0.1 times minus 0.2. Give us a figure. Give us a figure. According to Mary and James, they are getting 0.059. 0.059. How about the other students? If I could get like 2 more, I'm giving you exactly 3 minutes. 2 more students giving me this figure, confirming that this figure is correct, I will really sleep today a very happy man. Lucy says 0.0386. Lucy, check out. There must be a figure here that is quite different. There must be a figure that most probably you never took as a minus. Yeah, I'm even thinking so because I can see also your PPD is wrong. Yes, Lucy, just check the figures that we have here. See whether there is a figure that you've taken in as positive and supposed to be negative. Just be keen enough. Just take this. Check here. Just check. You can see March is also confirming the same figure, 0.059. Thank you very much, Lucy, for being yourself. You should always try as much as possible to be truthful. In a QA, you can never hide anything from anybody. QA, you have to be very truthful for you to be assisted. Very honest for you to be assisted. So Lucy, I'm still waiting for you to tell me whether you have seen out some mistake. The other big mistake that I normally see my students getting into is when they try to do like these things separately. Anapata hii andika kando, tena apate hii andike kando, tena apate hii andike kando. Hiyo utapata makosa kubwa sana. Inafaa unapiga zote kwa calculator round 1. Thank you very much. How about kadra? Kadra sijakusikia tena ukiongea kadra. Please, usikaone kama ni kitungumu. Hakuna kitungumu hapa. Hakuna kitungumu hapo. So 0.059 is correct. Thank you very much, ladies and gentlemen. Having gotten that, please let it not get lost on you that at the end of the day, what they wanted us to give them is the determinant. At the end of the day, what they wanted us to give them is a determinant. And for us to get the determinant, we normally take PPD minus PSD. PPD minus PSD. PPD minus PSD. I forgot to ask Miriam whether there is anything that she was able to get, any small concept, however small, she has been able to pick so far, like how to get PPD, how to get PSD, Miriam. Beautiful. So the PPD that you guys gave me earlier on, minus this PSD figure that we have here, then according to March, we should be able to get 0.219. Thank you very much, Mary. Thank you very much. So, ladies and gentlemen, I've been able to get the determinant. And if you recall, we said a 3x3 matrix has got 4 basic steps. A 3x3 matrix has got 4 basic steps. We never completed all of them, but I simply ignored the incomplete question purposely, because I wanted us to basically brush through the concepts using this particular illustration, Now, ladies and gentlemen, having gotten the determinant, I will straight away remember that we have 4 basic steps. We have the determinant. Number 2, we have the minor. Number 3, we have the cofactors. Number 4, we have the inverse definition. I'm repeating again the basic steps of ascertaining the inverse, of a 3x3 matrix. Number 1, give us the determinant. Number 2, give us the minor elements. Number 3, give us the cofactors. Number 4, give us the inverse definition. So, ladies and gentlemen, remember, which matrix do you want to inverse? We want to inverse I minus A. This matrix is the one we want to inverse. So to inverse it, I've been able to get its determinant. Now I want to get the minor elements. So the minor elements, what am I going to do to get the minor elements? To get the minor elements, minus 0.1, 0.85, minus 0.2, minus 0.12, minus 0.28, 0. What here? 0. The last one is 0.48. So this is the matrix whose minors I want. This is the matrix whose minors I want. I want the minor elements of this. I want the minor elements of this. So could you kindly go ahead and give me the minor? The one thing that I will always remember about the minor is that if they want me to give them the minor of this value, each of these values here will be having a minor element. So if they want me to give them the minor of these, what am I going to do? I'm going to hide the value row-wise and column-wise. You hide the value row-wise and column-wise. Listen, anytime you want to get a minor element, you hide the value of interest row-wise and column-wise. Once you do that, you'll be left with what we call a submatrix. Like in our case here, this is the sub. And once I have the submatrix, remember by definition, minor element is the determinant of the submatrix. I'm repeating again, minor element is the determinant of the submatrix. So please go ahead and give me the minor of this thing. Go ahead and give me the minor of the submatrix. Is there anybody who is able to give me the minor? Is there anybody who is able to give me the determinant? Remember, determinant is product of primary minus product of secondary. Determinant is product of primary minus product of secondary. So product means that I'm multiplying. So product means I take 0.85 times 0.48 minus. Remember that the secondary must always be put in brackets. So when you are getting the minor, ladies and gentlemen, we take the product of the primary minus product of the secondary. The product of the primary is this 0.85 times 0.48 minus open brackets always for the secondary. Please ensure that you are doing exactly what I'm telling you. Take the product of the primary minus open brackets for the secondary. Secondary is minus 0.28 times minus 0.2. Close the brackets and give me an answer. And it has to be given to us by all of us. It has to be given to us by all of us. So I've seen much. I've seen what much has given me. I've seen what Areba has given me, even though it's wrong. Areba would want you to go and repeat, but I'm really appreciating, because I know whenever a student really takes effort to give you an answer, that is a student who is trying to understand. Hata akipata wrong, I don't really care. So long as I make an effort ya kupatia figure, that's a student who is getting out of his way, out of her way to understand. Thank you very much, Kadra. I can see you have gotten it right. I would want to get answers from every student. So the minor for the first one, I'm being told is 0.352. is 0.352. Now listen. Now we want to get the minor for the second. So how do we get the minor for the second? If I'm using, ladies and gentlemen, a pencil, what I need to do, if I'm using a pencil to cover my values, what I'm supposed to come and do here is to rub. And then now I'm targeting the second one. This second one, the rule for getting its minor is clear, crystal clear. The only thing that I'm supposed to do is to come and cover it row-wise, and then we cover it what? Column-wise. We cover row-wise and column-wise. And the moment we do it that way, ladies and gentlemen, now we need to be able to figure out the sub-matrix, those elements which are left uncovered. Once I see them, then getting the determinant of the sub-matrix, the 4 elements which are left uncovered, is as easy as a walk in the park. Is as easy as a walk in the park. So I need to identify the elements which are what here uncovered, the 4 of them. I have this and this, primary. Remember primary first. So the primary here should be minus 0.1 times 0.48. Minus 0.1 times 0.48. And then I say minus. Minus are always open brackets for the secondary. Lucy, thank you very much. I can see what Lucy has given me. So minus 0.1 times 0.48. Whatever I get, I'll say minus open brackets for the secondary. If these are my primaries, the secondaries will be an interchange like that. So the secondary here will be minus 0.12 times minus 0.2. Could somebody in this case here give me the answer? I like what I'm seeing. Match has come up with a different answer from what Lucy gave us, which is very good because that now means democracy. So I would really expect a third student to give me a figure. A third student to give me a figure for me to be able to know who is correct between Lucy stroke Match. But again, ladies and gentlemen, even if you're to get it wrong, so what? It doesn't matter. Even if you're to get it wrong, it doesn't matter. That is the essence. We are learning. So all these guys are giving us minus 0.072, minus 0.072, minus 0.072. How I wish Miriam can give me an answer, even 1. Miriam akinipatia answer 1, niona ameunderstand kakitu, I'll be very happy. Nikilala leo, nitalala na viatu. So they're giving me a figure of minus 0.072. Please, Lucy, try to repeat. Let's repeat together. So in this case here, they want us to give them the minor of this element. So how do we get the minor of this value? You hide it row-wise and column-wise. And then we'll be left with the 4 elements uncovered. Thank you very much, James. The 4 elements uncovered, we are talking of minus 0.1 times 0.48. Minus, in my calculator, after I say minus, I'll say open brackets for the secondary, because the secondary must always be kept in brackets. The secondary must always be kept in brackets. Thank you very much, Lucy. Yes. Now, I would want you guys to continue and give me the minor of this, the minor of this, the minor of all of them, the minor of all of them. As you get in this case here, you answer, simply give us minor for value 3. Minor for value 3 equals what? Minor for value 4 equals what? So Vinny and Lucy are agreeing about the third figure, but those are too few students for me. I can see James has a different figure. March has a different figure, but they're agreeing with what James has. So Lucy, I don't know, this 0.074 is for which? Is it for member 3? Vinny and Lucy, you need to tell me. I'm liking the figures that I'm seeing. Now, ladies and gentlemen, let me do only one. So we have here 0.7 minus 0.2 minus 0.1. We have minus 0.1. We have 0.85. We have minus 0.2. We have minus 0.12. We have minus 0.28. We have 0.48. So if they want us, ladies and gentlemen, to give them the minor of this, what I will do, if they want me to give them the minor like a kid, right? So what I'll do, I'll have to hide this kid. Kids are normally hidden. So you hide the kid who is this, you hide him row-wise and the column-wise. And if you do it that way, then you'll be able to see the submatrix. The submatrix, ladies and gentlemen, which is left uncovered here, is this minus 0.1 times minus 0.28. Minus, please, if you forget the brackets of the secondary, you'll always be wrong. So you're saying here, it is minus 0.1 times minus 0.28 minus, because I've taken this and this, minus, open brackets here for what here? Our secondary. So our secondary, ladies and gentlemen, is now this. So it will be minus 0.12 times 0.85. Could you kindly confirm that this will give us, according to what Quadra has given us, please confirm whether you'll get 0.074 negative. Please confirm. And then now Lucy is giving us minus 0.124 here. Thank you very much. James is giving us 0.324 there. The fifth one. So please finish up all of them. Okay. Thank you very much. Thank you very much. I can see now all of us are in agreement. I can see what Veni has been able to give us there as a benchmark, like now for member 7, 0.125 is exactly the same figure that Lucy is getting. I'm waiting to see the other figures from the other students. I'm waiting to get the other figures from the other students. I know why. I'm normally patient. I'm normally patient whenever it comes to these things. Thank you very much, Kadra. Member 5 is 0.324, correct. Lucy has finished, crowned it by giving us number 8, negative 0.15, that I would want to confirm with what my sister had here. Great. Member 8 is negative 0.15, what Veni had given us. Member 8, you can see what Mary Wanza is giving us. Thank you. You can see what 𝐭𝒐𝒎𝒐𝒏𝒘𝒆𝒂𝒍𝒕 has as member number 8. So the minor there, the minor for member number 8 or minor 8 is 0.15. Much has been able to confirm nothing. The ninth one, March 9th, ama umefinya 0 kimakosa, hiyo iko kubwa sana. Ama ni 0.5. Oh, yeah. 0.575. Thank you very much. Thank you very much. Thank you very much. 𝐭𝒐𝒎𝒏𝒃 has also gotten. So, ladies and gentlemen, what I'll do is simply to come and copy the figures that you guys have. The figure that you guys have, we have 0.124. Then we have 0.324. Thank you very much. We have 0.22 here. Thank you. 0.22 here. Then we have 0.175, 0.125. Then we have negative 0.15, negative 0.15. And then we have 0.5, 0.575. Thanks. Those are the minor elements. I can see there is a message here. M3. M3, I'm told, is supposed to be 0.13 from March. From March. Can somebody confirm that M3, my M3 here is wrong? Can somebody confirm my M3 is wrong? James is still getting 0.13. Thank you very much for bringing that argument. We learn best in quantitative analysis. We learn best through what here? Making arguments. We learn best through making arguments. Same answer. Let's see. So you see for member 3, where are we? Like that, like that. So what do we have? We have minus 0.1 times minus 0.28. That is the primary diagonal. Primary diagonal, you don't have to put it in brackets. Secondary, so minus the secondary, which will be minus 0.12 times, let us leave whatever we are doing all over us. Let's concentrate on this third minor element. Let's concentrate on this third minor element, and then we compare notes. Let's concentrate here, somebody. For minus 3. Please, using your calculator, all of us are now concentrating using your calculator. Minor element 3. Inafaa ikuwe ngapi, somebody? Yes, James had confirmed that. But minor element 3. Minor element 3. Could you kindly give me an answer? I know the problem normally comes because of this negative which is inside here. Please, I'm your coaches. I'm your coaches. When a coach tells you to run like this, you don't run to any other thing. I'm a coach, and the coach has asked you to stop doing whatever you're doing, and then you give us this answer from your calculator. From your calculator, James has been able to confirm that 0.13. Lucy has gone back to M1, and I want them first of all to. Mary has confirmed. So this 0.13, this figure is supposed to be 0.13. 0.13 positive. Thank you very much. Thank you very much. And I know where your problems began. I know where the rain began beating you is in whatever that is where? In the brackets. In whatever that is in brackets. In whatever that is in brackets. In whatever that is in brackets. So ladies and gentlemen, the moment I get this right, there is a student again who is telling me that there is another figure that is wrong. Which figure is that we do together? Which figure is wrong? Which figure is wrong? Is it minus 6? Minus 6? Among the figures that I have, I'm being told there is a figure that is wrong. This minus 6 here. So for minus 6, what am I supposed to do? For minus 6, ladies and gentlemen, this is quite a simple thing. Quite a simple thing. This is quite a simple thing. For minus 6, ladies and gentlemen, this is what I have. I have here 0.7, minus 0.2, minus 0.1, minus 0.1, 0.85, minus 0.2, minus 0.12, minus 0.28, 0.48. So I would want to test this minus 6. Minus 6. Kwa hivyo nitakuja hapa the baby, I hide the small dota like that. I hide the dota row wise and the column wise like that. And then I'll be left with what here? I will be left with my minus. So this minor element, I will have to get, not minor elements, but I'll be left with my uncovered submatrix. So this uncovered submatrix, what do we have here as the PPD? It is 0.7 times minus 0.8 minus open brackets. So if this is the primary, the secondary will be the other one. Minus 0.12 times minus 0.2, like that. So could you kindly confirm this figure? Kindly confirm that figure. Somebody is giving me negative 0.22. Is there somebody else who is able to confirm that minus 0.22 is the thing? Somebody confirm that this minus 0.22 is the thing. Somebody have to move with speed. Thank you very much, Miriam. Thank you very much, Lucy. And any figure coming from Miriam makes me very happy. She was not there in our yesterday's class, but she has gone out of her way kusema mimi sitajirilia. Kwa maisha sio vizuri kujirilia. Kwa maisha unajipigania. Mimi nitajipigania na amepata figure correct. I really appreciate. So now I want to believe that all the figures that we have now are correct. We don't have any figure that is wrong. So I'm making, in this case here, the last call. If you think that there is a figure that is wrong here, kindly talk to us. Should you fail to talk to us at this particular state, when we progress and you realize that there is a figure that is wrong, please don't raise that matter up. This is like how they do it in the figures are okay now. Thank you very much. So ladies and gentlemen, now having gotten the minor elements, remember what you have gotten are called minor elements. Having gotten your minor elements, the next thing will be for us to get what? What do you think in this case will be the next thing to be ascertained? Once you have gotten the minor elements, what do you think will be the next thing to be ascertained, ladies and gentlemen? Once you've gotten the minor elements, what do you think could be the next thing to be ascertained? Ladies and gentlemen, talk to me kindly, Cofactors. Yes. So come and give us here cofactors. Basically, to get cofactors, we use the diamond rule. We use the diamond rule. So you use the diamond rule, and at this particular juncture, I would want to know whether there is any of my students here who has ever seen a diamond, real life, a real diamond. Is there any student here who has ever seen a diamond? Leave alone those things that you normally see in cartoons and movies. No. Real. Somebody who has ever held a diamond on his hand like this. Is there anybody? Is there anybody who has ever seen a diamond? Is there anybody who has ever seen a diamond? No problem. Ladies and gentlemen, can we round off 2 digits or we work with it the way it is? Remember, the issue of rounding off, really, it's about you. If you wish to work with fewer decimal places, nobody will penalize you. If you wish to work like myself, these figures, I'll just work with them, they are, I'll be still correct. At the end of the day, we'll get answers that are so close to each other. So, ladies and gentlemen, once I reach here, I want to reiterate the fact that for cofactors, we normally use the diamond. This diamond has got many corners. In particular, our diamond here has got 4 corners, and this diamond normally touches external row and the columns, central elements. So, ladies and gentlemen, listen. Normally, the diamond touches the central elements of the external rows and the columns. How I wish a student can just pick it the way it is literally, that my diamond has got how many corners? 4 corners. And each of those corners here will go where? Will go to each of those 4 corners here will go to, each of these 4 corners here will go to where? Each of the 4 corners will go to these central elements of external rows and what here? Columns. Now, ladies and gentlemen, the moment you are there, now you are at a very good position of giving us the cofactors. Once you've been able to draw the roadmap for your cofactors, for your diamond, now the cofactors will be very easy for you to ascertain. How do you ascertain them? Now you will come and write the figures that we have. Every figure has to be brought here. Every minor elements figure has to be brought there. The only difference is that any figure that has been touched by the corner of the diamond must have its sign changing. Any figure that has been touched by the corner of the diamond must have its sign changing. So like now, this was initially negative. Now it becomes what here? Positive, like that. This becomes positive as well, 0.13. So come here. Here what do we have? It was negative. Now it becomes what here? Positive. So basically the cofactors and the minor elements are gonna be the same, except for the fact that all the minor elements that have been touched by the corner of the diamond must always have their signs changing. So we have here 0.324. Here we have positive 0.22. Here we have 0.125. Here now we have 0.15. And then lastly, we have 0.575 like that. Those are the cofactors that we have. So what are we learning? We're learning something very important regarding development of the cofactors, regarding the ascertainment of the cofactors. Great. Now, ladies and gentlemen, from that, we'll go to the last step. The last step is the one of inverse definition. So you go to the last step, which is the step of inverse, definition. So remember the matrix whose inverse we wanted is this matrix I minus A. So I minus A inverse will be equal to what? I minus A inverse will be equal to what? I minus A inverse will be equal to 1 over the determinant times the cofactors transposed. Times the cofactors done what here? Transposed. So I minus A inverse equals 1 over the determinant times cofactors, done something special, times cofactors transposed. So I minus A inverse will be equal to 1 over the determinant times the cofactors done what here? Transposed. So ladies and gentlemen, if that is the case, then my I minus A inverse will be equal to 1 over the determinant that we got in part 1. 1 minus the determinant that we got in part 1 that ostensibly have forgotten. I would want someone to remind me. There's a determinant figure that we got in part 1. Who is able to remember that figure? 0.219. So this is 0.219, like that. Times the cofactors transposed, times the cofactors, thank you very much, James, times the cofactors transposed. Ladies and gentlemen, to transpose a matrix means what? To transpose a matrix means changing rows to become columns. Changing rows to become columns. Changing rows to become columns. So how do we change rows? Like now the first row becomes column number 1 downwards. So to transpose a matrix, I'm repeating again, to transpose a matrix means changing of rows of the original matrix to become columns. If you have taken that, that will be very good. So row number 1 becomes column number 1. So we have here 0.352. We have 0.072. We have 0.13. So this is row 1 that has become column 1. So row 2 becomes my second column. Row 2 here. Row 2 here we have 0.124, 0.324. Then we have 0.22 like that. And then we have row 3 becoming column 3. So row 3 becoming column 3, we have 0.125, 0.15, 0.575, like that. So ladies and gentlemen, this is our I minus A inverse. Please, I would want to rest a little bit for 2 minutes. And of course, when I'm resting, I'm expecting somebody to ask questions. Please ask questions. Please ask a question. Ask a question up to where we have reached. Are you comfortable? Are you comfortable up to where we have reached? Are we comfortable? Are we comfortable up to where we have reached? Yes. Thank you very much. And please, I would want you to go and repeat this thing immediately, because I'm so sure there are very many students who get to fear it, but really there is nothing. There is nothing. There is nothing. So I'm still waiting for students here to respond, perhaps to affirm that you're together for me to continue. Lucy says yes, 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 yes. Or 3 by 3 matrix. Thanks. Ah, great, great, great. Now, ladies and gentlemen, once you have gotten now the inverse nicely, we know that the next thing that you have got to do is to recall the formula. Recall the formula. Recall the formula. Recall the formula that we wanted to get here. Remember our input-output equation says that our x should be equal to I minus A inverse multiplied by D. Multiplied by D. Thank you very much, March. So multiplied by D. So our x here will be equal to this thing that you have. These are I minus A, which is 1 over 0.219 into the whole of this. The whole of this. Then we have 0.124, 0.324, 0.22. We have 0.125, 0.15, 0.575. So this is our I minus A inverse multiplied by our matrix D is the one that we gave you when we started the question up there, which you don't have now on the board. I deleted mine long time ago. So I would expect a good student to come and give me this matrix D. The final demand, we call it the final demand. So matrix D, is there somebody who has those figures who can remind us very fast the figures, we put them down? So the figures, would want to put the figures down. Thank you very much. 60, 90, 100. But remember, they have to be captured in the form of what here? In form of a column. They must be captured in form of a column. So ladies and gentlemen, now what I'm going to do is quite a simple thing. What I shall do, I can see I've got a scalar and then I've got two matrices multiplication. So I'm going to leave the scalar outside. I'll come and talk over 0.219. I leave the scalar outside. And then, of course, I multiply the matrices themselves first. So how do I do my matrix multiplication? A simple thing. Matrix multiplication, Roman Catholic. Matrix multiplication, you run down the ditch. Matrix multiplication like this row 1 by this column. This row 1 by this column. How do I do it? The first figures multiplied. So we have 0.352 times 60 plus the second one's multiplied plus the third one's multiplied. Please, somebody do that and give me an answer. What I know at the end of the day, ladies and gentlemen, QA is all about your confidence. There is nobody really who knows QA that much. Even Mwalimu will be surprised you are even better off than me by far. The only thing that I have is the confidence that I can make a mistake and it doesn't really bother me. So long as I know I've made a mistake and then I correct my mess, that's okay. You become a mathematician. Mathematicians are basically those people who don't fear making mistakes, who will always want to be involved. Get involved. So ningechukua tu figure ni multiply na niseme nimepata answer tofauti. In the process, all of us are going to learn. So we have March giving me a figure that is different from what Mary Wanzer has given us. It seems whatever Mary Wanzer has is correct. It's correct. Angalieni hapa, what are we doing? We are saying the first one's multiplied plus the second one's multiplied plus the third one's multiplied plus. So Miriam has been able to give me a figure of 44.78. But I'm not seeing the other students talking to me regarding that, because most of them are not bold to give us wrong figures. We always learn best by making mistakes. We always learn best by making mistakes. I'm repeating again that you always learn best by making mistakes. We always learn best by making mistakes. Thank you very much, James. Thank you very much, Veni Brianna. Thank you very much, Kadra. So that is it. And then, ladies and gentlemen, what I'll do, I'll come and multiply this second row with this column, the second row with that column. So what I will do, it doesn't matter which row, which column you're giving me, so long as I'm fine to do with the Roman Catholic, so long as I'm fine with my Roman Catholic procedure, then I'll always be correct. So what I need to do is to come and take first one's multiplied plus second one's multiplied plus third one's multiplied. You give us a figure. 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 Aha. James tells me it's 48.48, and somebody else has also been able to confirm that figure. I've seen it moving very fast. Thank you very much, March. Thank you very much, Veni. Thank you very much. And then now we have the last row with this column. The last row with this column. And then you advise me, what do we have at the end of the day? What do we have at the end of this with this? Please give me figures. Please give me figures. Please give me figures. Please, 85.1. Thank you, and thank you very much. And then now what we're going to do lastly, this figure has to multiply each one of them. Has to multiply each one of them. And then now you get 3 answers. So like you take this divided by this times that, you give me a figure. This divided by this times that, you give me a figure. So this has been amongst my most interesting classes with you because of how you got out of your way to participate in what so many students have always been saying is a hard concept. So ladies and gentlemen, kindly come and give me this divided by this times this. Give me a figure to write. Give me a figure to write. So Mary Wanza gives me 154, 154.41. Go to the second one, this divided by this times this. Give me a figure to write. Give me a figure to write. So we have 204, different from whatever I have, different. So this divided by this times 44.78. Let me wait for somebody else to confirm these figures. Different. So Veni gives me what Nani has up there, 204.47. The second one is this divided by this times this. Please give me a figure. So we have this divided by this times this. Please give me a figure. 388.58. 388.58. And then the last one is this divided by this times that. 221.36. 221.36. 221.36. 221.36. And that is the answer. That is the final answer. So the thing that I would want you to go and do, just like the students I taught last semester, you know, most of them thought that I'm an examiner. No, I'm not an examiner. Normally what happens is that because of my experience, I know the areas to knock. So like now this is an examinable area, 221, or 221 is the second one. I'm being told 221 is the second one. How about the third one? How about the third one? So like now this is an examinable area. So if it's an examinable area, what you do, you will go and repeat. You'll go and repeat this question from the beginning to the end, having put your answer far, far, far away, far, far away, far, far away. So the third one is 388, 388.58, 388.58, 388.58. Otherwise, ladies and gentlemen, because of the curfew, naomba kabisa nikimbie. There is nothing really I can start right now. Nikimbie. I hope today you guys have gotten some little value. Thanks. Bye. Okay.